Hello, welcome back to my channel. So in the previous video we already mentioned the first principle of differentiations. So let's recall back the dy dx will be equivalent to the limit when the change in x is approaching 0 del y or del x. So, and this will be equivalent to limit delta x to 0 and fx plus delta x minus fx over del x. Alright, so from the first principle we actually derive some formula that we can apply in the differentiations. So for differentiations, from the first principle we derive 4 formulas. So the first one is the basic formula. I call it as basic formula is because it's quite basics, as we already learned it in the secondary school. So when we have example y equals to ax to the power of n, when we differentiate it, it will become dy dx, where we take n in front, become nax, and this n, the power will be reduced by 1. Alright, let's take an example from just now, e.g. y equals to 3x squared minus 5x. So when we differentiate it, it will become dy dx equals to, we take back the 2 in front, so 3 times 2 will be equals to 6, and x, this power reduced by 1 will be 1, so we don't need to write, so minus 5, because when we take 1, 5 times 1 will equals to 5, and x to the 1 minus 1 will be x to the power of 0. Anything power of 0 will equal balance to 1. I hope you all understand. So this one is the same answer when we use the first principle. Hence, we know that this formula is derived from the first principle. Alright, so how the derivations actually is not important for your syllabus, so I won't talk it. So the second thing is the chain rule. So actually chain rule is also quite simple. So but chain rule is very important concept that will be applied in your university level as well if you're taking the engineering or mathematics courses. So know that dy over dx is equivalent to dy over du times du over dx. Actually it's the same thing. When we cancel out the du, it will be same as dy over dx. So why we don't use this? Because we want to let a function as u. Alright, so let's say we have y equals to a fx, and fx is a function of x. It is not constant, not a constant. What means by constant is like 3, 55, 32 plus 1 is not like it is not a constant. In this case, the fx is something like 3x, 5x plus 6, 6x squared plus 8x cubed, something like that, is with the variable x. Alright, so now we're going to solve this. How are we going to solve this? So dy dx in chain rule, we let this one equals to u. So we apply the basic formula we learned just now. We take back the n, so we become na. So what this bracket we should write? We should copy back. We copy back the same things, but the power is the same as the basic formula reduced by 1. Since we already skipped the differentiation as in this part, we already copy back, so we must differentiate it and multiply back with the functions. So this one is the differentiate terms of this one. Okay, I know it's complicated, so let's take an example. So this example is like, let's say we have y equals to root 3x. So when we apply the chain rule method, y equals to root 3x, and we know actually square root is the power of half. So now how are we going to differentiate these terms? So it's basically like dy dx will be equivalent to, we take the half as just now the basic formula, and now we copy back the terms. That means we didn't move this. This is the function, this is the fx. As you can see, here is the fx, and n minus 1. We know the half minus 1. Okay, so now we must multiply back. You don't forget this one. So we differentiate the things inside the brackets. So we know that d dx 3x will be equivalent to 3, right? So we multiply with 3. This one is differentiate the term inside the bracket where the term is a function. So as we will get 3 over 2, 3x half minus 1 is negative half, and we will get the answer. So you get something like so it's here is 3x, and substitute we get this x half. So if we but one thing important, that if we apply the basic formula method, it will be different ways to solve these questions. Let's say we have using the same example, y is root 3x. For using the basic formula, you can't let this. If you let this, you will get wrong answer, because as you see, if you differentiate like that, you will get sorry. So I'm sorry. So here is supposed to be like here. So this one is definitely wrong. So in this case, if you apply the basic formula, because you forget to multiply 3, so it will be wrong. So if you apply you want to apply the basic formula, I don't care, I want to apply these formulas, so you must separate it out with the constant and the variable. The constant and variable must be separated. So as you get, this one is root 3, this one is x to the power of half. Then you can apply the basic formula where you take the half in front. So you get root 3 over 2 x half minus 1 is equals to negative half. So it's actually the same answer with the chain rule. So I hope you can see the difference. Never mind, we will do more examples in later. So the third thing is product rule. Product rule is quite basic. I can say it's quite necessary formula to you to learn when we have y equals to uv, where u is a function and v is a function, and we get dy dx equals to u dv dx plus v du dx, or we can say as y prime equals to uv prime plus vu prime. How I remember this? Actually, it's like that. So you can think like that. U and v is completely different functions. Or we can say that like this one is 3x and this one is 5x squared plus 1 then power of 2. So we must differentiate it separately, since we cannot, if we expand it will be very complicated, so we don't want to do that. Right, so you can do like, or we can add uv is something like sine x, then this is 2x. So they are completely different functions, so we must use the product rules. So how I remember this is like, okay, like two friends, you are going to a barber shops, but there are only one barber. So now you all must take turn, right? So something like that. Okay, you and me go to the barber shops and you all want to have a haircut. So y prime equals to, okay, I'm sitting on the chair, I'm waiting for you. Okay, b prime first. Okay, now we already finished, so he sit here. So then you go to haircut. So it's like that, uv prime plus vu prime. So it's just like very easy to memorize. Yeah. So let's give an examples. Let's say we have y equals 3x to the power of 5 x squared plus 1 to the power of 4. In this case, if you want to expand, of course you can expand it, but if you expand the power of 4, it will be very complicated, and I don't suggest you to use that things. Okay, so how about you take this as u and you take this as v? So we can just, so let u equals 3x to the power of 5, v equals to x squared plus 1 to the power 4. And we separate it, okay? So we know that du over dx will be equivalent to 3x, right? So 5 times 3 will be 15x to the power 4. Where dv dx, we must apply chain rule, right? 4 we bring in front will be 4. So this one, we copy back. Don't forget to multiply your differentiations inside the brackets. So when we differentiate this, we will get 2x. And we will get 8x. X squared plus 1. Oh, I'm sorry. So it's 4 minus 1, so it's get 3. Alright, so when we get this, we know the formula. So we copy back this. Okay, now I wait on the chair. So now we will go to the haircut. So we copy this dv dx 8x x squared plus 1 cube. Then now I already finished cut my hair, so yeah, you copy the v x squared plus 1 cube. Then you times with the, now u is going to the haircut, so it's 15x to the power 4. Oh yeah, this one is 4. Alright, so you can get the final answer is 3x to the power 4 x squared plus 1 cube and 8x squared plus 5x cube plus 5x. Alright, so these are the answers. So I would tell you if I have an advanced method like this here. So here is for the advanced method, but if you cannot do that, is okay. So when you have this one, you can just divide the x, you know that. So we must copy this one to x5, and now we differentiate this one, we will get 4 x squared plus 1, and this is 4 minus 1 is 3, and we differentiate inside, we will get 2x, and we plus. Now I already finished cut my hair, now your turn, 3x power 5, so you become x. So we copy this one, x squared plus 1, for I'm waiting for you, so you will get 15x to the power 4. So when you multiple, you will get 24x 6 x squared plus 1 cube plus, and this one here you will get 15x 4 x squared plus 1 power 4. And you simplify it, you will get 3x 4 x squared plus 1 cube and x squared plus 5x x squared plus 1. Alright, so you can further let me see. Yeah, you can expand it, or you don't need to expand it also, okay? X squared plus 1 cube 8x squared plus 5x cube plus 5x. Yeah, it's okay. It's the same answer with this. Yeah, same answer as you can see. Alright, so I must tell you some extra knowledge. You must remember the barbershop theory. It's like here. Okay, I have y equals UVW. That means 3 friends are going to the barbershops. So how I gonna define the dy dx? So actually dy dx will be equivalent to the same thing. So now u will waiting for the w for cut his hair, and plus UVW. So now we are waiting for me to cut his hair, and we plus. So UVW. Now you will cut his hair. So it's like taking turn. They will taking turn to differentiate, and they are good friends, so they will follow when they are cut their hair. So to differentiate this, so if you get something slightly, if you have UVWX, that means you will be 4 terms, and if you have plus more terms, you have plus the 4 terms together, so it's the same things, right? So many terms are okay for the differentiations. So the last theory is the quotient rule. So product rule is about multiplications, and quotient rule is about the dy. Yeah. So when you have y equals to u over v, this is the completely 2 different functions or very complicated function that you don't want to expand. Let's say we have sine x over x, or cos x over 3x squared plus 5x. It's a very complicated function. Then you can use this formula. So how are we gonna find the dy over dx? So in this case, alright, so how we remember this? I just draw a line here, So the v, I square it. Alright, so I put back the v here. Now, I will du dx this one. Du dx. And quotient rule is minus. This is different with product rule. Product rule is addition, right? So here is minus signs, okay? So, and you will get, so you, just now we already differentiate this, so you minus u, and now we differentiate the v, dv dx. So here is the formulas. Alright, so if you don't want u, and actually u equals to u over v, you know that 1 over v is equals to v to the power of -1, then you can u equals to v to the power of -1, then you apply product rules. I would say this one is simpler, but sometimes if you can't really apply the product rule, you must apply the quotient rule. Then here is the only way you must memorize this one. It's quite easy to understand. Actually, you just remember that you need to square this, then copy this, and differentiate it at the last. Alright, so let's say we have this one, 2x plus 1 over 3x squared plus 5. I would say that if you want to expand it here, it's quite impossible, so you must use the quotient rule, divide x. So we draw a line first. So in first steps, we will take this one, then we square it, so it becomes 3x plus 5. Okay, now we copy back this 3x squared plus 5 square root, and multiple with differentiating of 2x plus 1, you get 2. And now remember it's a minus sign, and now we will copy back the numerator 2x plus 1 and differentiate the denominator. How to differentiate this one? Alright, so how to differentiate? You can do it aside, it's okay for SDBM. Okay, so you can 3x plus 5 to the power of half. If you want to dy dx of these things will be equivalent to left y, so you can half, yeah, apply your chain rule, then this one copy back the things inside the brackets, and this one become negative half because half minus 1 is negative half, and we differentiate the terms inside the brackets, you will get 6x. And you copy it down here, you will get half 3x plus 5 negative half 6x. Then you can further simplify it. Yeah, you become 3x squared plus 5 minus half 3, we get 2x plus 1 3x plus 5 negative half over 3x squared. Here is 2 plus 5. So here is the answer. So actually here is the 4 simple formula from the derivation of first principle of differentiation. So in next video I will explain about the implicit functions where you can differentiate it, and the differentiations of trigonometric functions. I will derive every single things, okay? And here is the basic formula where we learned in the secondary school, so I hope you all can revise it back and take some exercise that, yeah, alright. That's all for this video. Thank you for watching.